The Fantastic Five, Romeo, Daisy, Anthony, Connery, and Jude. Line 5 minds, one mission. Pushing boundaries, solving problems, encoding the future. Together, we're unstoppable.
What is virtualization? Well, virtualization is the process of creating a virtual version of something, like servers, storage, or networks, using software instead of physical hardware. Why it matters? It lets one physical computer run multiple virtual machines, saving money, space, and resources. Think of an apartment building. One building, physical server, can hold many apartments, the virtual machines, each with its own tenant, operating systems, or an app.
The simple answer? Virtualization makes one physical computer act and perform like many computers. How? Every computer has 4 attributes: processor, memory, storage, network. So virtualization works like this. Take a big computer with plenty of processing, memory, storage, and network capacity. Install a piece of software called hypervisor. This physical machine is called the host. The hypervisor manages the physical resources of the host so that the virtual machines can use them as they need to. Guest computers run inside the physical hardware. They act exactly as though they were physical machines, but they aren't. They're just big files. Why would you virtualize? Run many servers on one physical server. Save money on hardware. Upgrade virtual machines hardware with mouse clicks. Disaster recovery. Virtual machines are files, so the entire VM can be backed up. Not just the data, but the OS, installed programs, the whole thing.
Alright, so now let's dive into the different types of virtualization. First up is server virtualization. Imagine you have one powerful physical server, but instead of dedicating it to just one task, you split it into multiple smaller virtual servers. Each one acts like its own separate computer with its own operating system and applications. This saves money because you don't need to buy a ton of physical servers, and it makes managing workloads way more efficient. A real-world example is VMware or Microsoft Hyper-V. Next is desktop virtualization. This is where you don't necessarily need a physical computer sitting in front of you to run your desktop environment. Instead, your desktop is hosted on a central server and streamed to you over the network. So you could be on a thin client, a laptop, or even a tablet and still have access to the same desktop. This is popular in schools, hospitals, or call centers where you want consistent, secure desktops for lots of users. Then we have storage virtualization. Think of this like pulling together multiple physical hard drives and presenting them as a single big storage system. It simplifies management, improves performance, and makes backups easier. For IT admins, instead of juggling 10 different drives, they see just one logical unit of storage. After that, there's network virtualization. Normally, your physical network is tied to switches, routers, and cables, but with virtualization, you can carve up that same network into multiple virtual networks. This allows better security, faster configuration, and the ability to test things without breaking the physical setup. A big part of this software-defined networking, which lets admins control the network through software rather than hardware. Finally, Let's talk about the benefits that cuts across all these types. Virtualization saves costs by reducing the need for physical hardware. It's flexible and scalable. You can spin things up or shut them down quickly. And it improves disaster recovery because your systems aren't tied to one single machine. So, in short, whether it's servers, desktops, storage, or networks, virtualization helps us use technology, resources more efficiently, securely, and in a way that scales with demand.
Good morning, everyone. My name is Anthony Davis. Today, I'll be talking about cloud computing models, both the service models and the deployment models, and I'll give you real-life scenarios to make them easier to understand. Let's start with the service models. First, infrastructure as a service, or IaaS. This is where companies rent virtual servers, storage, and networking instead of buying expensive hardware. The provider takes care of the physical equipment and you manage the operating system and applications. For example, imagine a startup launching an online store. Instead of buying servers, they can use Amazon Web Services or Microsoft Azure to rent computing power. This way, they only pay for what they use and can scale up during busy shopping seasons. Next, Platform as a Service, or PaaS. This gives developers a ready-made environment to build and deploy apps without worrying about the underlying infrastructure. Think about a software team working on a new mobile app. They don't want to waste time setting up servers or databases. By using Google App Engine or Azure App Service, they can just focus on writing code while the platform handles scaling and maintenance. Finally, software as a service, or SaaS. This is the most familiar model to most of us. Here, the provider manages everything and you just use the software through the internet. For instance, a small business might need email, document sharing, and video calls. Instead of installing software on every computer, they can simply use Google Workspace or Microsoft 365. It's easy, affordable, and always up to date. Now let's move on to the deployment models. Public cloud. This is like renting an apartment in a large complex. It's shared, affordable, and managed by the provider. For example, a small business might use Google Cloud Storage or AWS S3 to store files at low cost without buying servers. Private cloud. This is like owning your own house. The entire cloud is dedicated to one organization, giving more security and control. A bank, for instance, may use a private cloud to securely manage sensitive financial data. Hybrid cloud. This combines both public and private. Think of it like living in a house, but also renting an apartment when needed. For example, a hospital may keep patient data in a private cloud for security, but use the public cloud for research analytics that require heavy computing. And lastly, community cloud. This is a cloud shared by organizations with common goals like a co-op, housing community. A good example is several universities creating a shared cloud to collaborate on research and securely store data. To wrap up, IaaS is like renting land and building your own house. You control most of it. PaaS is like renting a fully furnished apartment. You just bring your furniture, or in this case, your code. SaaS is like booking a hotel room. Everything is ready. You just use it. And for deployment, public cloud is the apartment complex, affordable and shared. Private cloud is owning your own house, private and secure. Hybrid cloud is having both, a house plus an apartment when needed. Community cloud is the co-op community, shared by groups with common needs. In short, cloud computing gives us flexibility, whether we want full control, easy collaboration, or cost savings. And real-life services like AWS, Azure, and Google Workspace show us these models in action every day. Thank you.
Thanks, Anthony. So now that we know about the different cloud models like LAS, PAS, and SAS, you might be wondering, why do businesses even bother moving to the cloud in the first place? Well, that's where I come in. I'll be talking about the advantages of the cloud, but also the challenges. Because just like superheroes, the cloud has some weaknesses too. So here is our mission, which is the Cloud League versus the Kryptonite Crew. And here summarized is the advantages and challenges. So the advantages would be the cost efficiency, the scalability, the global access, and the disaster recovery. We're going to go through all the advantages as well as the challenges, which are the security, downtime, vendor lock-in, and compliance issues. Then later on, we will be looking at a case study and putting this example into real life. Meet our team of superheroes in the cloud, the advantages. Alright, so let's imagine the cloud is like a team of superheroes. Each hero has a special power that helps businesses. First up is Money Saver Man. His power is saving money. Instead of companies buying a bunch of expensive computers and servers, they just rent what they need from the cloud. That's way cheaper. Next is Stretch Girl. She can grow super tall or shrink really small in seconds. That's like the cloud. If a business suddenly needs more power, the cloud can give it instantly. If they need less, they can shrink back down and not waste money. Then we have Time Rewinder. His power is turning back time when disaster strikes. If files get deleted or a server crashes, the cloud can restore everything from a backup. And finally, World Connector. She connects people all over the world with the cloud. You can work on the same project with someone in another country at the exact same time. Isn't that awesome? But every superhero team has its villain. The cloud has weaknesses too. It's kryptonite. In this slide, we'll be talking about cloud's kryptonite, its challenges. The biggest villain is the hacker villain. He tries to break in and steal data. That's a huge risk for businesses. Then there's the sleepy server. Sometimes the cloud just goes down when it does. Websites or apps can stop working for hours. Another enemy is the sticky glue trap. Once a company picks one cloud provider, like Amazon or Microsoft, it can be really hard and expensive to switch. They kind of get stuck. And lastly, the rulebook cop. He represents all the laws and rules companies have to follow. Different countries have different privacy rules, so using the cloud can get complicated. Now, let's put this into a real story. Everyone knows Netflix. Imagine it's a Friday night and the new season of Stranger Things just dropped. Millions of people hit play at the same time. Normally, a company's computer would crash under that pressure. But thanks to the cloud, Netflix uses its superpowers. Stretch Girl helps them scale up instantly so millions of people can stream without buffering. Money Saver Man helps them avoid buying thousands of servers. They just rent what they need. But the villains, they can attack too. If Amazon Web Services, AWS, the cloud Netflix uses, has downtime, guess what? Stranger Things stops working. For everyone, people on Netflix, why is Netflix down? That's the sleepy server. And of course, they have to protect users' accounts from hackers. That's the hacker villain. So basically, the cloud is like a superhero team. It saves money, scales fast, and connects people everywhere. But it's not perfect. It still has villains like hackers, downtime, and strict rules. And that's the balance companies have to deal with every day when they use the cloud. Thank you.
Hey everyone, this is Carmiri. I will be talking about future trends and the conclusion of our project. I will be defining edge computing, hybrid cloud, AI integration with cloud, and how virtualization and cloud computing shape the future workplace. A recap and final thoughts. Future trends. Edge computing. A simple definition is process data closer to where it's generated. And why it matters, it reduces delays and improves real-time performance. In a real-time analogy, like having a coffee shop on your street instead of waiting for one across town. Hybrid cloud. Definition. Mix of public and private cloud. Why it matters, it balances scalability with security. A real-time analogy, like keeping valuables in a home safe and a bank vault. AI cloud. Definition. Cloud powers AI and machine learning at scale. Why it matters, enables augmentation and smarter decisions. A real-time analogy, like Netflix suggesting shows just for you. Netflix uses an AI integration to know and suggest certain shows that it knows that you would like. Future workplace, remote access, meaning virtual desktops and cloud apps can let employees work anywhere. Collaboration, tools like Microsoft 365, Google Workplace, and Zoom, like what we're on now, thrive on the cloud. Agility, companies can scale its resources quickly to meet demand. Cost savings, less need for expensive hardware, pay only for what you use. Security and continuity, cloud backup and disaster recovery protect business operations. So if your hardware or if everything that is backed up on your hard drive completely disappears, hopefully, and you'll have everything in the cloud. So this is a conclusion of cloud computing and virtualization. Reducing costs. Virtualization maximizes hardware by creating multiple virtual systems on one machine, while cloud computing delivers services and storage over the internet. Together, they improve efficiency, reduce costs, and make advanced IT accessible to everyone. Looking ahead. With trends like edge computing, hybrid cloud, and AI integration, they will drive innovation and transform the workplace into one that is more connected, agile, and intelligent. Knowing how to use these technologies will be the key skill for the workforce of tomorrow. But the future will be even more disruptive. Edge computing, hybrid cloud, and AI integration will make technology faster, smarter, and everywhere. AI is already moving into offices, hospitals, and even fast food restaurants. And it will replace many human jobs in the years ahead. This is not science fiction. It's happening right now. To stay relevant, we must learn these technologies, adapt to the changes, and use AI as a tool instead of being left behind by it. Thank you for listening to our project. Now enjoy a rap song about cloud computing and virtualization.
System booming. Loaded virtual layers.
We in the cloud, can't slow us down. Virtual machines keep spinning around. A plus knowledge stacking like a boss. Tech on demand, no downtime, no loss. Virtualization, that's the foundation. One machine running multiple nations. Hypervisor split the system tight. Type 1 bare metal, type 2 on site. Say the hardware cut the cost. One server, mini OS not lost. Snapshots roll back when it's broke. Spin up a clone, that's more than a joke. We in the cloud, can't slow us down. Virtual machines keep spinning around. A plus knowledge stacking like a boss. Tech on demand, no downtime, no loss. Now the clouds where the big dogs play. IS past SaaS all day. Infra you rent, no racks to buy. Scale it up quick, resources fly. On demand service, uptime prime. Pay as you go, no wasted dime. Public, private, hybrid too. Choose your flavor, it's all on you. Remote desktop storage sync. VM migration in a blink. A lag hosted growth is infinite. Cloud computing, we live in it. We in the cloud, can't slow us down. Virtual machines keep spinning around. A plus knowledge stacking like a boss. Tech on demand, no downtime, no loss.